Torque. Defining terminology. James Thomson, the brother of Lord Kelvin, introduced the term torque into English scientific literature in 1884. However, torque is referred to using different vocabulary depending on geographical location and field of study. This article follows the definition used in U.S. physics in its usage of the word torque. In the UK and in U.S. mechanical engineering, torque is referred to as moment of force, usually shortened to moment. These terms are interchangeable in U.S. physics and UK physics terminology, unlike in U.S. mechanical engineering, where the term torque is used for the closely related resultant moment of a couple. Torque and moment in the U.S. mechanical engineering terminology. In U.S. mechanical engineering, torque is defined mathematically as the rate of change of angular momentum of an object. In physics, it is called net torque. The definition of torque states that one or both of the angular velocity or the moment of inertia of an object are changing. Moment is the general term used for the tendency of one or more applied forces to rotate an object about an axis, but not necessarily to change the angular momentum of the object, the concept which is called torque in physics. For example, a rotational force applied to a shaft causing acceleration, such as a drill bit accelerating from rest, results in a moment called a torque. By contrast, a lateral force on a beam produces a moment called a bending moment, but since the angular momentum of the beam is not changing, this bending moment is not called a torque. Similarly, with any force couple on an object that has no change to its angular momentum, such moment is also not called a torque. Definition and relation to angular momentum. Proof of the equivalence of definitions. Units. Torque has the dimension of force times distance, symbolically T2L2m. Although those fundamental dimensions are the same as that for energy or work, official C literature suggests using the unit Newton meter Nm and never the joule. The unit Newton meter is properly denoted Nm. The traditional imperial and U.S. customary units for torque are the pound-foot lbf-ft, or for small values the pound-inch lbf-in. In the U.S., torque is most commonly referred to as the foot-pound, denoted as either lb-ft or ft-lb, and the inch-pound denoted as in lb. Practitioners depend on context and the hyphen in the abbreviation to know that these refer to torque and not to energy or moment of mass as the symbolism ft-lb would properly imply. Special cases and other facts. Moment arm formula. Static equilibrium. For an object to be in static equilibrium, not only must the sum of the forces be zero, but also the sum of the torque's moments about any point. For a two-dimensional situation with horizontal and vertical forces, the sum of the forces requirement is two equations, H equals 0 and V equals 0, and the torque a third equation, T equals 0. That is, to solve statically determinate equilibrium problems in two dimensions, three equations are used. Net force versus torque. When the net force on the system is zero, the torque measured from any point in space is the same. For example, the torque on a current-carrying loop in a uniform magnetic field is the same regardless of your point of reference. If the net force F \displaystyle \math f f f f f f f f f f f f math f f f f is not zero, and T1 \displaystyle boldsymbol \tau1 is the torque measured from R1 \displaystyle math R1, then the torque measured from R2 \displaystyle math R2 is Machine torque. Torque forms part of the basic specification of an engine. The power output of an engine is expressed as its torque multiplied by its rotational speed of the axis. Internal combustion engines produce useful torque only over a limited range of rotational speeds, typically from around 1,000–6,000 rpm for a small car. One can measure the varying torque output over that range with a dynamometer and show it as a torque curve. Steam engines and electric motors tend to produce maximum torque close to 0 rpm, with the torque diminishing as rotational speed rises due to increasing friction and other constraints. Reciprocating steam engines and electric motors can start heavy loads from 0 rpm without a clutch. Relationship between torque, power, and energy 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 and energy. Power and energy and energy and energy. Proof. Conversion to other units. Derivation. Principle of moments. Torque multiplier. Torque can be multiplied via three methods: by locating the fulcrum such that the length of a lever is increased, by using a longer lever, or by the use of a speed-reducing gear set or gearbox. Such a mechanism multiplies torque as rotation rate is reduced.